Python is a very popular programming language. In fact, it's the most recommended programming language for absolute beginners to start with. However, there are a lot of people who don't really understand the journey of learning Python. What is the learning path? What steps or levels they have to take or go through in order to master the Python programming language? In this video, I'm going to talk about the 6 levels or the 6 steps that will take you from being an absolute beginner in Python to being a master in Python. So let's jump right into it. The first level is what I call level 0. Level 0 is if you are either an absolute beginner to programming in general, or if you are coming to Python from a different programming language. The only difference is the time it will take you to learn the concepts at this level. What are the concepts that we're talking about here? So the concepts we're talking about here are not concepts that are exclusive to Python. At this level, since you are just beginning your programming journey, you will be learning concepts, fundamental programming concepts that are not just specific to Python, but you can use the same concepts and you'll find the same concepts in any other programming language that you'll be learning in the future. What are these concepts? For example, variables. What variables are and how to use variables. Functions. How to use functions in your programs. The different operations that you can perform in your data. For example, how to do arithmetic operations like addition, multiplication, subtraction, or how you can do comparison operations, greater than, less than, equality operators, or even logical operators, or all of that fun stuff. And in addition to the operations, also the types, the different data types that your programming language supports. For example, integers, floating point numbers, strings, lists, all of these different data types are also things that are not just specific to Python, but you'll see the same concepts in other programming languages as well. So what I really want you to focus when you are at this level is don't get bogged down by the Python specifics, but try to understand the fundamental programming concepts themselves, because it will help you if you want to learn any other programming language in the future. In this level, you're also going to be learning about loops, like for loops and while loops, and these are statements that you can use if you want to repeat the same block of code over and over again. And you will also be learning about conditionals, like if statements. And this will allow you to write programs that will behave differently based on a specific condition. So all of these concepts, like I said, are very important. They are fundamental, and you will see them in any other programming language you will ever learn. When you combine all of these concepts together, this is when you can actually start writing code that is useful, that is doing something useful. The best way to learn level 0 and to master level 0 is to write a lot of code. And there are a lot of problems out there that you can actually solve after mastering the concepts of level 0. So make sure to write a lot of code and make sure you really master this level very, very well, and you really internalize and understand these concepts because they're really fundamental. Level 1, object-oriented programming in Python. Object-oriented programming is a programming paradigm. It's a programming model. It's a way of thinking, looking into a problem and then trying to structure the solution of a problem using what we call objects. Like I said, by finishing level 0, you are very qualified to actually start writing code. But the code that you will probably be writing at this level, level 0, is most likely to be procedural code. Procedural code is also a programming paradigm. It's a way of thinking where you look to a problem and then you solve the problem by having a bunch of functions that solve smaller problems. And then you solve the bigger problem by solving these smaller problems. This is basically how most of us start learning any programming language. We start by writing solutions, writing code in a procedural way. The next step in the journey is to learn about object-oriented programming. It's a different way of thinking about the problem and structuring your solution, but it is very important for 2 reasons. Reason number 1, most of the widely used programming languages these days are object-oriented programming languages. If we talk about C++ or Java or Python, All these three programming languages, they're very widely used in industry, and all of them are object-oriented programming languages. Number two, the object-oriented programming paradigm is actually very simple to understand, and it helps you write readable, very efficient code. And again, it's very widely used in industry. So you really need to master this programming paradigm if you want to be a good software engineer in general. And similar to level 0, the object-oriented concepts are fundamental concepts that are not specific to Python. So for example, concepts like inheritance, polymorphism, composition, all of these concepts are concepts that you will find in all of the programming languages that support object-oriented programming. So again, what you're learning here is not going to be specific to Python, but you can use the same concepts and the same knowledge when you go from learning Python to learning, say, Java or C++. So this is very important. So again, I would focus 100% on really understanding the concepts before you try to learn how to apply these concepts in Python, okay? Once you understand these fundamental concepts, you can then see, okay, how can I create a class in Python? How can I create an object in Python? How can I inherit from another object? Or how can I override a method? So to summarize, the best way to learn object-oriented programming in Python is, number one, start with learning the object-oriented concepts in an abstract way. Don't think about Python for now. Try to understand what a class is, what an object is, what the concept of inheritance means, what the concept of encapsulation, polymorphism, and so on and so forth. Once you mastered these concepts, the second step is to make sure you understand how to apply these concepts to Python. So how to create classes in Python, how to create objects in Python, how to say, oh, I want this class to inherit from this other class, how to override methods, okay? And then the last step is, again, solve a lot of problems. You can even go back to the same problems that you solved in level 0 and see if you can solve the same problems using object-oriented programming. So again, at this step, the best way to learn is to write a bunch of code. Now let's talk about level 2, socket programming in Python. So far, what we've been doing is we've been writing code that runs on our machine, which means you have a laptop, you write code on your laptop, and this code just runs on your machine. You have not written any code that interacts with other code that is written in a different machine. For example, say you have 2 laptops in your home, and you want to write code in one laptop that communicates with code in another laptop. How can you do that? This is what socket programming allows you to do. And in order to master this level, you will also find that you really need to master the fundamental concepts of computer networking before you master how to use libraries in Python that allows you to do socket programming. Let me clarify. For example, you need to understand what TCP is, what UDP is, what's the difference between TCP and UDP, HTTP, which is also a very important application layer protocol, and it's very widely used. Every time you just type google.com or facebook.com, you're basically communicating via HTTP. So it's very important to understand how these protocols actually work under the hood, because even if you're using Python libraries that make this job easier for you, these Python libraries can't really abstract away all of these concepts from you. So you really need to understand these fundamental networking concepts before you start using these libraries that will make things easier for you. It's very important, okay? I will link down below to my favorite book about computer networking. It's written in a very engaging way. It's not boring at all, and it will give you all the basic fundamentals that you need to understand so that you can master this level. All right, after mastering these networking concepts, now it's time to write code again. So pull out your laptop and start experimenting with the different Python libraries that allows you to write network programs. For example, let me give you some examples. You will find libraries that allows you to communicate over TCP or UDP. You can start by writing something called an echo program. An echo program is a simple program. It's like the hello world for socket programming. So it requires at least 2 computers because we want 2 computers to be talking to each other. One laptop is going to run the server side of the program, and another laptop will be running the client side of the program. The server side is just going to be listening over the network for any message that comes to this laptop. And the client side program will be sending messages to the server side. And what the server will do, every time the server receives a message from the client, the server will echo back this message back to the client. So all of this action is actually happening over the network. So if your 2 laptops are connecting through Wi-Fi, these messages are actually communicated over the Wi-Fi or over the LAN that you're having at your house. Okay, it's pretty cool. And the first time you write a program that communicates between 2 computers, you'll be extremely happy because let's be honest, it's really magical and it's beautiful when you get to do that. Another library in Python that is useful if you want to write programs that communicate over HTTP is to use the requests library from Python. It really makes your life easy if you want to send an HTTP packet to another computer. A very good exercise here is to, for example, use Facebook or Twitter, both Facebook and Twitter, and most of the services out there, web services, they provide an HTTP API interface so that your code can communicate with them. In other words, basically, you can write a post on your Facebook or basically post on your Twitter from your Python code by sending an HTTP packet to the Facebook server or the Twitter server or Google Maps. You can basically just get a navigation from one point to another point by communicating to the Google Maps server. So this will be a great exercise for you after you master this level, is to basically look at these services, look at their HTTP interfaces, and see how you can communicate with their API servers and do these things. For example, like I said, just go to Twitter, look at their API documentation, and see what HTTP packet you should send in order to be able to post a tweet, for example, using HTTP. But be careful, these different services, most likely they will have SDKs that will allow you to do this in Python the easy way, but this is not what you want here. You basically want to send a pure HTTP using the requests library to the service, because this is how you're going to learn about HTTP. If you're using the SDK that these services provide to you, you're not going to be learning a lot here. Another thing that is very useful to learn at this level is learning all the different tools, networking tools that you can use that will make your job easier, maybe troubleshooting your programs if there's a bug or trying to understand what really happens under the hood. I recommend looking at TCP dump, which is a terminal utility, or something like Wireshark, which is if you're more of a user interface type of person. Both of them do the same thing. They allow you to actually look at the contents of the network packets that goes out of your machine to another machine, which is very useful, especially when you're learning the fundamentals of networks. It's very useful to use programs like these because you'll be able to see the actual packets that eventually goes to the wire or goes to the Wi-Fi, and you can see, you can check the contents of these packets. It's amazing stuff. Of course, you don't really need to do that once you start writing Python programs, but it's good from a learning perspective. So yeah, TCP dump and Wireshark. Lots of documentation online. Level number 3, concurrent and parallel programming. Up to this level, the way we've been writing code is we've been writing sequential code, meaning that the way we think about the code that we write, we think that the code will be executed sequentially. So every instruction in our code will be executed sequentially. However, if we actually look at the underlying hardware that our code is running on, for example, if we have a laptop, we have a processor with multiple cores, or we can sometimes have multiple processors on the machine that we're using. So we need to learn and understand how to take advantage of this underlying hardware. And the way to take advantage of that is to run pieces of your code in parallel so that your code runs faster and more efficiently. Of course, that is if your code is parallelizable, if you can parallelize your code. However, writing parallel code is not easy, and there are a lot of bugs that can happen in your code if you're not paying attention. For example, assume you have a shared variable x, and you have two processes that wants to increment x by 5. You would expect that the final value of x will be incremented by 10. However, if you're not careful, then you might find that the final value of x is very different from what you expect. And the reason why this might happen is because of something we call in computer science race conditions. What are race conditions? Basically, whenever you are trying to access a shared variable through different processes that are running in parallel, then a race condition might happen, meaning that the final value that you would expect is going to be very different from what you get. If you want to know more about race conditions and why they actually happen, I will link down below to an article that explains more about why race conditions happen. Now, the question is how to protect against race conditions. If we don't want our code to be buggy, how do we protect against that? There are many mechanisms that protect against race conditions. All of the mechanisms are called synchronization mechanisms. One of the most popular synchronization mechanisms is called the lock-in mechanism. And the idea is very simple. The idea is if you have multiple processes and a process wants to read and write to a specific shared variable, then this process needs to acquire a lock before it can read or write to this variable. And the idea is if the process can't acquire a lock because it's acquired by another process, then the process has to wait until the lock is released. So process 1, for example, can acquire the lock and then read and write to X and then release the lock. Process 2, however, cannot run in parallel with process 1 because when process 2 wants to acquire the lock is already acquired by process 1. Process 2 has to wait until process 1 releases the lock. And this is one of the many different ways you can protect against a race condition. All right, now everything that we've talked about has been fundamentals about parallel programming in general. Now, if we want to be specific about Python, here's what I want you to do. I want you to start writing parallel programs using these 3 parallel modules: the threading module, the queue module, and the multiprocessing module. All of these modules will provide you with the primitives you need to start writing parallel programs. Another thing that is worth mentioning here is if my application really needs efficiency, and if I really need to parallelize the code that runs my application, then I'll probably not use Python for that. I'll probably use something like C++ or Java or Go, because these are more efficient languages for parallel programming and they utilize the underlying hardware more efficiently. Level number 4, data structures and algorithms. So far, if you've mastered all the previous levels that we talked about, you are an awesome coder, my friend. I can give you a task and you know how to solve this task. But that is not enough. To understand why that is not enough, imagine the following scenario. Imagine that I am your manager, okay? I ask you, here's a problem. I want you to write code to solve this problem. So you go ahead, write some code, and fair enough, you answer the problem. However, when you give me your code, I run your code and it's very slow. It's inefficient. It's running very slowly. So I come back to you and ask you, hey, can you make your code run faster because it's running very slow and I don't understand why. Here's the problem. You don't understand how to make your code run faster. You don't even understand why your code is running slowly in the first place. And the reason why that is because all of the things that we talked about before in the previous levels, none of these things talk about efficiency. None of these things talks about how efficient your code is. And by efficiency, I mean either how fast your code runs or how much resources does your code use. So in order to be able to answer to your manager and actually make your code run faster, or even come back to your manager and say, hey, we can't really make this code run faster because of these reasons, you really need to master data structures and algorithms. This is what's going to take you from being an average coder to being a solid programmer. Data structures and algorithms, again, it's a computer science subject, so a solid understanding of data structures and algorithms is not going only to help you in your Python journey, it's also going to help you if you want to learn any other programming language as well. Some of the things that you will want to learn is linked lists, trees, graphs, hash tables, dynamic programming, sorting algorithms, searching algorithms, and so on and so forth. Again, this step is very crucial if you want to level up and be a solid programmer. The last level, advanced Python. So this is the level when you take your Python learning to the next level. This is going to be specific to Python, and these are going to be the things, the concepts in Python programming language that is more advanced. For example, things like generators, decorators, higher order functions, context managers, coroutines, and so on and so forth, metaprogramming as well. All of these are advanced concepts in Python, and for that I highly recommend a book called Fluent Python. This is my favorite book on advanced Python concepts. It skips all the beginner stuff and jumps right into the more advanced concepts that you need to learn if you want to take your Python mastery to the next level. Okay, so these are the 6 levels that you have to go through in order to master the Python programming language and in general be a solid software engineer. However, depending on the kind of application that you're writing, there are some libraries in Python that can make your job easier. And you might find it useful to also learn some of these libraries. For example, if you're writing API servers, then I highly recommend you learn Flask. If you're writing web applications, then I highly recommend you learn about Django. If you want to be a data scientist, if you're interested in machine learning, then I highly recommend you learn about scikit-learn and NumPy and pandas for numerical analysis, which goes hand in hand with machine learning. Good luck, and I'll see you in the next video.